Awesome. Yeah, so my name is Evan, and I'm a React engineer at NYC. We are currently building a extensible email client all in React and Flux. But this, like most apps, started off fairly simple. But over the past several months, it's grown into tens of thousands of lines of code and dozens of stores and components all over the place. We had some growing pains along the way. Now, so we've gotten better at managing that. A little bit of what I want to talk to you about tonight is how that's scaled. So tonight, I'm going to be talking about a better way to handle Flux in large and complex applications. Sort of the end punchline of that is that we found when we have tons of these interconnected stores, it was getting very difficult to keep a clean declarative pattern. So our solution actually was to centralize all of that in a big top-level store and make a lot of things hierarchical. We'll go into a little bit more about what that means in a bit. But first, let me introduce Flux. Now, for those of you that have built an app with Flux before, the next couple slides should be review. But to sort of get us on the same page, let me show you how this works, first of all, with a very simple example. So let's say that we wanted to build a list of email messages with React and Flux. So this is actually pretty much all there is to Flux. Flux is a design pattern. It's a cleaner, more declarative way to manage your data in React applications. Now, there may be many libraries you may have heard of. There are different implementations of Flux. For example, there's Fluxor and Reflux, and Facebook actually has their own Flux.js implementation of it. But for the sake of this talk, we'll only be referring to sort of this design pattern that sort of Facebook has coined with this ecosystem that we have called Flux. So at the core of Flux, there are these green boxes. There's stores. And stores are responsible for holding all of your data for your application. In our case, in this message list example, it would be the one that's holding all my email messages. Now, stores are not models in the traditional MVC sense. So first of all, in the Flux design pattern, all the stores are singletons. There's only one of these. There may be many, many, many views. And this store's job has a couple main functions. Its primary one is to sort of cache and aggregate all of my messages in meaningful ways, and then ideally immutable copies of that data through these public getter methods that the views will consume, and finally listen for actions that cause data to change, and sort of see how that goes around this one-directional loop in a second. The next is sort of this React component. This is a traditional React component you see here. This would be one that, for example, is rendering a list of email messages. The way this works, though, is that anytime that message store changes, it fires this trigger event. And the minute it fires a trigger event, the message list component here will get new, fresh data from the store. So it always has a fresh set of data that it has from this store that it listens to. And now finally, instead of using like mutating methods on the store, we have this concept of actions in a dispatcher. So anytime a user wants to take an action, for example, say someone wants to delete a message and like pushes something on the UI, the store will fire an action. It'll actually get globally broadcasted through this dispatcher, and then it's the store's responsibility to cache that action again. Once it catches the action, it will update its state through sort of whatever business logic it has in there, called trigger again, which will cause the component to fetch the data and refresh itself. So that's sort of Flux in a nutshell, but this is this key pattern that keeps everything declaratively bound to the data. It ensures that the views never get out of sync. And it also ensures that it's an accurate representation of the data. Because if the data would ever change in that store, the trigger would cause everything else to update immediately. This single directional loop where actions cause mutations, which cause them to trigger and grabbing the data, this is sort of the central dogma of Flux, and what makes this pattern work well sort of as applications scale. However, when it's like this, it's nice and simple, we found that as you start adding more objects in your system, things get complex pretty quickly. Now, if you only ever have a small amount of data, or you never need composite data, then congratulations, you might not need to listen to this talk. But as we found very quickly, that's rarely true. We sort of defined this increasing complexity build as we added more things to specifically our message list there. So let me sort of walk you through what that looks like as the complexity grows. So say, for example, we have this list of messages, and we want to know when the thread changes, because you want to display a list of messages like that. So instead of having some sort of imperative method that goes and it mutates something inside of the store, the way we do this with Flux is I have this message store listen to another store, listen to a thread store in this case. As soon as some data changes in the thread store, like my currently selected thread, it will cause the message store to get all the new data that it needs, update itself, and the view retriggers again. Now, having stores listen to other stores is actually a very common unsupported design pattern in Flux. It's sort of what helps you, instead of being imperative about the way things change, it allows you to be declarative. It allows you to say that the message store's state, like internal state, is proportional to what's currently happening in this thread store. So now I can say this list of messages, but now I want to write an inline reply. I want to have this concept of drafts that I'm working on. So here again, we add yet another store. So whenever a new draft shows up in there, the message like that triggers, and it causes this message store to declaratively say, oh, there's a new draft, I should like get it, push it together, say I changed, and the view will update. So we can have these start chaining a bunch of different stores together. And now say that we introduce this concept of like a WebSocket, because I want to know as soon as a new message shows up, I want to live update it. So now I've implemented this WebSocket connection to get live updates from the server. These are actually notoriously a pain in a lot of applications, because if this was jQuery land and we got a new piece of data, we would probably just append a div onto the end as to what we have. But because this is React and we're doing things declaratively, we don't necessarily do it like that. Instead, we can say, oh, some new data has come in, and that will trigger, the message store will get that data, it itself will update, it will trigger again, and sort of the whole system will refresh itself to be accurate of what the current state of the world is. Now finally, let's say we add yet another piece, because requirements continue to grow, as you know, in building these applications. So say we had something that wanted to support multiple languages. Now we have this concept of this translation language store that we need to listen to, yet another piece to start listening to. As you can see, this message store is getting quite a few dependencies attached to it. So also let's take a step back to look at where we are when all of this happens, because it's not just this message store that has a lot of dependencies. All of these stores will too. And suddenly we end up with a little bit of a mess here. And this is sort of the crux of the problem when you scale with Flux. You get a lot of these intertwining interdependencies, and things just become very difficult to reason about. And the more you add, it becomes exponentially increasingly hard to reason about. And now when a change happens on the system, it's very difficult to see where it propagates to. There might be hidden circular references in here. These changes might be arbitrarily long. And furthermore, now you have this, like the ordering at which things happen starts to matter. In fact, React itself, like Flux, Facebook kind of acknowledged this, and they talk about sort of this need for the dispatcher in Flux. They're like, yes, things are complicated, they are interdependent. They have this concept of waits for, which means that as the actions come in different orders, because of all of these stores going all over the place, that the time and the ordering of that matters. So like, okay, so instead of getting ourselves into this increasing interdependent hell, we ended up coming up with one initially scary, but eventually we found an elegant solution to fix a lot of these problems. And what we did is that we centralized all of our data into one top-level store. So this is our global singular data store. It actually houses pretty much all of the data for our app, and crucially now it becomes the single source of truth for the state of the entire application. Now when you do this, there suddenly become no more cycles, there's no more error spaghetti here, there's far less redundant listeners, and it becomes much easier to reason about. And furthermore, it scales better. It also helped us decouple a lot of our stores, which led to a lot of cleaner, more isolated system as we grew. To sort of walk through how this would actually work, I'm going to show you once again this like WebSocket example here of how we get app into the new, get data into our application. So before, every store that wanted to get updates needed to individually listen to this WebSocket changing and triggering. There's a lot of extra listeners that were happening here is a lot of duplicated code. We needed to figure out where data was supposed to get shuttled to. So now actually, instead what we can do is we can take all of the new data that's coming in and just update this one data store, because it now represents the state of our app. And because of the way React listens and triggers, that state propagates to the rest of the system effectively immediately. Because everything is declaratively bound to that data, it is an accurate representation of the world from our single source of truth here. And suddenly changing state in the app becomes much easier. We can sort of manipulate this one central piece of data and have that happen. Now, when we described this data store initially as being this singular piece of global, shared, mutable state, we commonly got this reaction about what we were doing. And there is a lot of truth to this in if you're passing around shared references and pulling out the rug from underneath objects can cause a lot of awful Heisenbugs, and that's true. But in this case, this central store, it is global, it is mutable, and it is shared, but it is not necessarily evil. And one of the reasons of that is because of this like central dogma of Flux, because of the triggering mechanisms that are built into this design pattern. The minute anything in the data store changes here, a synchronous trigger will propagate through the system, telling each store to update as well. And this is this refresh-based mechanism that makes sure that everything that's listening to this always has an accurate set of data at any given time. Because anything changes, you call trigger, and that trigger propagates throughout the system. And furthermore, as it gets propagated through, a fairly common pattern people use is that data that gets passed is actually immutable copies of everything. In fact, like Ohm does this with ClojureScript and enforces that in its functional way, and it sort of guarantees that you don't run into the sort of evil parallel programming shared immutable state problem. And finally, this is also very robust to changes when they might come from anywhere. As our application grew, as actually we add on extra third-party things into our application, we can no longer necessarily guarantee who is going to be mutating data and when. So because of this, like any store, if it calls a mutation on this data store, that's safe and it propagates. Like the WebSocket can call a change, and that's safe and it propagates. You can actually open up the console in our system and just start changing data, and the whole app will refresh itself to be accurate based on the data that's stored there, which is a really nice simplification to make as like a lot of stores develop, as the composite data gets increasingly more complex. Yeah, because of that, everything will stay in sync. So one of the other lasting implications that we found after moving everything to this big data store is that it helped us think about our app in a much more structured and hierarchical way. As it grew and the views required a lot of composite data, we found that it was becoming increasingly difficult to think about which stores held which data, because some of them were related to specific views, some of them were sort of composite across a bunch of different views, some of them were individualized to data themselves. And what we realized when we modeled it like this was that each store was actually just a cached subset of its parent. It was sort of declaratively bound to be, I am a subset of my total amount of data here. And you sort of see that hierarchically, and we know that it always stays in sync because of this Flux trigger refresh pattern. So, for example, our data store is actually just a cached subset of everything on our API, right? It's like the last 3 months of messages where the database stores like the whole thing. And then subsequently, all the stores below that are sort of cached subsets of this whole data. Some are about threads, some about like messages with their associated counts that get computed along the way. And that sort of can continue to propagate down in this hierarchy. So you can always keep data at sort of the right abstraction level that you need it, and know that it will always be correct, that it won't go stale. And then finally, all of the components they will just update the minute any of this data changes. And it's a really good way to keep everything in sync. You no longer need to fear that a piece of code is going to be going out of its way, like changing something, and suddenly your view is inconsistent and not in state anymore. Because the Flux pattern, keeping everything at the data level, keeping everything in this data store, is the representation of the app. Everything else is declaratively bound to reflect what that is. And actually, one final piece that we found that was really convenient about having this data store here is that because it sort of represented the state of the app, we actually could persist this to local storage. You can keep it on the back end. If anything crashes, we can dump the database and ship it away, and we actually know we can replay it. Everything comes back to exactly the way it was because everything's declared in the bound to this one thing. Actually, on our application, we're using SQLite. Sort of the reason we can do that is because it's our email client is actually wrapped inside of Electron, which is a project that GitHub made to build desktop apps. It's pretty cool. They took Chrome and they strapped Node.js to it and let you build these complex React applications, but it looks and feels like a native desktop app. It's a native notifications and DIC icons and everything, which is why we can sort of persist it to something like that. But yeah, so this pattern here is, we found one of the more effective ways, and have been using it for quite a while, to keep this growing complexity, these increasing set of Flux stores under control. It drastically simplified the reasoning that we have to do about the app. It really helped keep things decoupled, and it finally sort of helped us guide figuring out where to put data as we thought about how it should be structured hierarchically. So even if you don't immediately restructure everything based on this talk, because I don't necessarily expect you to, it's certainly useful to remember that these interdependencies can and will happen as your app grow. And I hope these are, this type of technique is something you might be able to think in the back of your head as you also start to develop your applications as well. And of course, the plug, if you're interested in working on sort of applications like this, we're always hiring to pick up you. But yeah, that's sort of the run of my talk. I'm certainly now open the floor to questions or talk about this pattern and what you want.
Do you want to talk about how you guys have the plugin architecture? Have you built components on top of that, or no?
Yeah, so that's another thing I can mention too that's a little bit ancillary to this. One of the reasons we also really needed this this data pattern was because part of what we've been doing is building this application that allows third-party developers to easily build extensions into our email client. So imagine if it was 100 times easier to make a Gmail extension or an Outlook extension, except these are all React components that hook up to these Flux stores. So not only do I not have any idea what stores to listen to, there might be an unknown number of third-party stores that are loaded on our system. But because of this pattern, they can all safely update data in the database or listen to these events like, oh, the thread changed, the list of messages changed, and it's a much safer, more robust way to handle that. Even all the way down to the component level, which is another really nice thing about React. Like I might have this sidebar with an unknown number of trusted but third-party components that live inside of there. If this was a single top-down app, it'd be very difficult to sort of put them there. But because this is React and everyone's its own isolated component, I can load all the components in. We actually have this component registry, which is itself a store which loads components dynamically into regions of our application. Yeah.
So, my question I'm new to Flux, and so can you talk about what's inside the yellow box? Because before, right, you had this notion of threads are derived from the messages, and so do you have computation inside the box, or you just update everything and rely on this notion of immutable data to make sure you don't over-update?
Yeah, so inside of these boxes is normally something fairly simple, like an array or a hash. Like that's sort of where we're keeping the data. And actually, sort of just to make that a little bit more concrete, I can actually show you a little bit of code here. This is stored. Yes, this is in CoffeeScript, and specifically we're using Reflux as a store library, so don't get into the details there. But the point is that inside of the store, all you do is you have something that listens to actions, and when some actions happen. So this is where there's some amount of business logic. Like this onExpand message thing might set a bit on one of the objects in our array. And its only other responsibility then is to sort of, whenever anything changes, it updates itself and it calls this trigger method, which everyone else is listening to. And as soon as that happens, we refetch the data again through sort of a publicly accessible getter. Yeah. Yeah.
Yeah, so I like the pattern a lot. I mean, it's similar to, I guess, how Relay will work
Yes, yep.
when it's released. Question about those green boxes, like green stores. You know, did you keep them for like backward compatibility, so you don't have to refactor your components when you introduce this architecture? Or is there some other reason for having like copies of the central store?
We actually keep all the data around, like, because, and furthermore, we actually started to add more stores as a result of this, because then we could keep stores sort of just related to keeping track of the, like, current number of unread count read stored, right? Or like more specific things like that. And would sort of keep that data together. Because one of the problems you have is you start to, this is one common thing, you start to develop these stores that get increasingly monolithic because they have to listen to more actions, they have to handle more data. Like our initial draft store, the thing that dealt with email drafts, got enormous because it had all this business logic in it. And eventually we could start splitting that off, and have them all listening to sort of this like more abstract piece of data that represented what draft should be around at any given time. Yeah.
So is the work that the green stores are doing just translating the data? Is that just like, there's a large pile of data and I'm just going to sift out of that a smaller pile of data?
That's actually exactly right. And that is a really powerful mode of thought to be in, because traditionally models is where you jammed a ton of business logic, right? They sort of became this like catch-all of a lot of stuff. But when you sort of view it like this, you're exactly right. Like their only job suddenly is to like intelligently prune down the data to just what you need at that given time, and then like trigger whenever anything changes. So yeah, it does in fact do exactly that. Yeah.
So it almost seems to me like you kind of adopted React's hierarchical like state pop structure in the store layer, which I think is really cool because you have your top layer, manipulating the data.
Yeah.
Do you see this ever having to grow beyond just your yellow and green layer, where you have other hierarchies within the store structure, or do you always see it being a single component at the topmost level, trickling down?
Yeah, we actually found that it is a little bit hierarchical, but stores tend to be very wide, actually. We don't see, so the only difference between this and React components is React components, you tend to get these very deep trees, these very like component inside a component inside a component inside a component, right? And it tends to do with sort of where it happens to be on the UI. Stores intentionally is just sort of like, this is holding message data, this is holding thread data, right? This is holding like drafts or something like that, right? It's these collections of data that are kind of independent of where they geographically are in your application, which is why they tend to be a little bit wide. And the depth tends to come when we need to add complexity on top of that. Yeah.
So you're saying that third parties can extend, or actually you're the third party that are extending your, so might they have their own yellow store that's, or the way that your architecture is set up, that they have to actually extend your base?
Yeah, so if you want to add another store here because you want to add, like, I don't know, like anything like extra full contacts, like reportive-like information or something like that, right? Yes, you can have your own store, but one of the things they do is they can all listen, and we actually let them then subsequently mutate this main piece of central data. And that's somehow, that becomes safe to do because everybody because everyone listens to that and sort of is always an accurate representation of that state. But yes, you can in fact with this pattern make a ton of new stores, even ones you don't know exist when the app groups up. Yeah.
So is the only mutable part of this in the yellow top?
We tend to push like all of the mutability as high as possible because that's how everyone can hear that changed. Now, occasionally we will have some of these like things that are like really specific to like, I don't know, like the view state on a particular message sort of not necessarily need to be public data. But it does like, whenever these need to change, like whenever this needs to change the the set of messages, for example, like in this list, we can just go and update that at sort of this top singular level, this data store, this database effectively, and everyone listens to it and gets that update immediately.
So what are you using for the immutable part?
Actually, right now we do a deep clone and a freeze when it comes out, which is surprisingly, which we're a little worried about at the beginning because like that's a little bit of a hairy thing to do. The fact that we do that though enforces that most of the data that comes out like is a simple data object. And when it comes to performance in the application, manipulating JavaScript objects is trivial compared to like painting. So that tends to like not be an issue. Yeah. That.
If for the client you're doing kind of data manipulation, like translation or statistics, generating data on the client that doesn't come from the server,
Yep.
do you do any of that? And like where does that happen?
Yeah, if new data becomes available on the client, well, if you're going to do nothing but display existing data, then it's all sort of getters. You can just deal with this immutable data and display it. If you're generating new data, we will generally have this have a store that like captures that new data, pushes it up to the top, sets it there, and like everyone else can now listen to it as well. Yep.
So you're using the intermediary stores to capture actions and then push back up to the yellow block?
That's right. Yep. Yeah.
How do you, at what layer do you prevent everything updating all the time? Like, obviously, the components themselves can check if they need to update.
Yep.
But do the green stores also function to be like, hey, I didn't change?
Yeah, there is a simple, at that point that becomes an optimization because yes, so a lot of the times that triggers, it's not relevant to most people. There's a little tiny piece of metadata that says the type of change, so I can ignore it a little bit faster. But yeah, it's just not listening to a lot of that change. Actually, one way to test that the pattern that you have is in fact declarative is the fact that I call trigger actually isn't necessarily special. That just means that you should probably refresh now because there's new data here. But I could have triggers on a set interval loop that just asks everyone to refresh all the time. And that would actually be potentially be fine too. It's certainly inefficient, but the pattern is set up such that this trigger is nothing more than get yourself new fresh data because something probably changed. Yeah.
So it affects you push the line and CD to that giant middle box.
Yep.
So how would you unit test that? You just put all the tests there, or
Yeah, so all these stores can be tested independently. And at some point in this store, they're give me all of the threads from this data store. But we just stub that out. When I say give me the threads, it just returns my set of test data in what's there. So it actually makes it extremely testable at sort of the individual store level.
But then in the past, when you put the green box that one of the dependencies,
Yep.
you can mark one of them and keep markers. And you can unit test all these dependencies.
Yeah, and actually when it sort of was the spaghetti soup, we would have to stub out everything that it was listening to. And now it's much easier to just stub out the one place where it's fetching data from. And then we can just sort of pass it the data we need for that one test. Yeah? Got that?
So I'm interested a little bit in what just showing this out here, which was about new data on the client that we want to persist, and I'm kind of new to Flux. I don't, what is the interface between components and the store look like? Is there logic in the component?
Yeah. Yes. So let me. There is in fact sort of a way to do that. So this is now the React component, and really its only job, right? So once again, ignore this is CoffeeScript on top of basic React using classes here, but basically its job is it's got to render messages that comes in its state. As soon as it mounts, it listens to the store to change, right? So that's actually at the end of the day how that's happening. And then when it's on change, as soon as anything happens, it calls set state again. But instead of you manually passing that data, this pattern sort of always exists. You saw it set state, with the data you get back from the store, at which point now this is grabbing the data from the store. And then finally, if there's, and then that's how you can also initialize the data. But to specifically mention sort of how you would now interact with this, if you had an action, like you wanted to submit a form, for example, or you wanted to like add a new to-do item, right? That would be an action that would fire. So on here would be like an on-click, it would like send action. In here, it would grab this global action bus and say like, add a new to-do as the action, or like create new message. That action is then picked up by the store here, and then when it says this like, then that's the store's the one that's now actually changing the data, right? It's the one that is like adding this new to-do object, and as soon as that happens, it calls update and trigger, which causes the review to refresh itself with that new data.
And if you want like the store to like send that information to some server somewhere, that's all the store one has nothing to do with it.
That's right. And if the persisting to like an API endpoint would also happen in the store as well. So when it like updated its like local copy, it also sort of sends off this API request. And actually, when the API request comes back, it comes back through sort of our WebSocket or through the return, and it sort of sets data at this top level, which filters all the way back down again. Yeah. Yeah.
How do you handle error states, like when you're not sure if it's persisted and something like that?
It's actually very robust to that. So, for example, say we optimistically like add my to-do onto the end, like so it updates immediately. Some error comes back later. The error handler, which would probably be inside of the store or the method that called it, would just like find that object and rip it out of the data. But that's fine. It's like one less thing in the data. And now like that's sort of rollback state. And sort of everything, because you can update the data sort of any way you want, that once it gets propagates and it will like delete from the view. Yeah.
Is it actually a rollback, or are you saying you're pulling that object down?
It's at the end of the day, you just need to make sure that like the data that you're looking at is what it should be. So in the case of like my to-do didn't save, I should make sure that my array of to-dos doesn't have that item in it.
So it's by object that you're looking for that.
That's right. Yeah. Yeah. That's over.
How would you handle if you have like two stores that need to do an asynchronous thing one after the other? So one store sends some data to a web service. When that completes successfully, the other one has to do that.
Yeah, so if they happen, so if the two stores like sends off one request, another store sends off another request, if this one comes back first and the data, and it's like updates data here, then yes, for like, I don't know, 500 milliseconds, you will have it such that like the item has been added here, but I don't know, the metadata hasn't come back yet. But the way everything's declared and rewired up, like that's fine. If some view needs both pieces of data, it just needs to check. It's like, oh, this store has its data to come back, and this store doesn't yet, right? It's possible you could display an intermediate state, or you just don't display anything until both pieces of data are available.
What if the second one, you needed to wait for the first one to finish before the second one got kicked off? How would that second store know that the first one?
Oh, yeah, in that case what we do is like we actually also use state to keep track of things like that as well. So if like stores 2 like doesn't need to, like it asks for like, is this available yet? Like, is this object done? And it sort of can keep asking for that every time there's this fetch, every time this data mutates, and then depending on like whether or not this one's ready, like now I know that I have my data to like update myself. So it's a little, that part is a little bit different because like you try and think about things in terms of like how, if the state is like this at any time, even if I'm waiting on something over here, like I'm just sort of like constantly asking, is this available? Which is a little bit different than say if you like took them together and put it in like a promise all block. Actually, under the hood, that's actually really what a promise block is doing. It's sort of pulling the state of all of these different promises, and when it's done, it resolves. Yeah.
Okay, so when you have components, say for example, a login component that invokes like async action, say authentication, right? Do you have the action return the promise and then you do then catch to figure out the state of that component, or do you persist the result of that action in the store and then have the component listed to the store?
Yeah, actually, we debated for a while about like how to use actions with promises, right? Like, should you fire an action like please add my to do and have it like a resolve callback on that? The answer was intentionally no. We intentionally did not have, you cannot listen to what an action returns. It returns nothing by design. And the reason for that is because we don't want you to say like add my to do, then like append something here, right? It's like fire the to do, and like now it's the store's responsibility to like deal with the server, get that data, and persist it to the data. Because instead of waiting for it then to call back, I'm waiting for a trigger. Someone eventually, if it works, will trigger, and I'll like fetch the newest state. And if it's in the newest state, then great, it must have worked. If it's not, then maybe something broke. But like me, the component, I don't really need to care anymore, as long as it's in the data.
Not your responsibility.
That's right. Yeah.
So what about errors then, right? Like if it fails to persist or something like that, you want to tell the user about it, what does that look like?
Yeah, so like things like a notification, for example, if something fails and like if I put the logic in the store, that'll actually push a new notification object onto this notification store, which subsequently like displays to the users. Yeah. Or it'll like push something onto like an error array that someone like is declaratively listening to. Yeah, one more?
Yeah, it's kind of a basic question, I guess, but if you have a component that's going to like update some field on a piece of data, like are you passing references to these objects back, or are you just passing like an ID and a field name? Like, how does that work?
Passing references to like other stores, or?
Well, like you have some message and you want to update its body content or update the to list or something.
Yeah, a very common pattern is when I say like get state from stores, like pass an ID. And I'll look something up by ID. So yeah, it is passing around a lot of IDs to like find all the objects. Yeah, okay, yeah, last one.
Yes, one more quick question. Like when you're doing like asynchronous data fetching, right? Or you have this like data fire hose, that shoots data through the WebSocket, right? Do you ever come across this like dispatcher cannot dispatch while it's already dispatching error, and how do you handle that? Like, do you have a queue ahead,
No, the actions fire a lot. Like they're flying all over the place all the time. So no, but there are occasionally sometimes where yes, a lot of the refreshers, right? Because I just need to refresh. I'll like put that on the debounce. But actually, a beauty of this pattern is that like that refresh method, like please refresh the data, that can be on a pretty long debounce. Like if stuff's changing underneath me like all the time, but I only pull for that once every 50 milliseconds or something like that, like that's fine. I'll just like catch it and whatever the state is when I pull it again, which is a really nice property of this, just like fetch, because I don't need to care if like there's a lot of stuff mutating underneath me quickly. When I refresh and I get it back, it'll be the state I want to display. Cool.
Cool. We'll see. Does this work?
Yeah, sure.
I get it.
Oh.